Example 4, a rectangular opening 12 inches long must have the same total area as two smaller rectangular vents, 6 inches by 4 inches and 8 inches by 5 inches. What must be the width of the opening? All right, so notice there's no picture. Okay, and geometry problems in general, pictures tend to help us visualize what's going on in the problem and helps us to figure out how to do it. So it tells us we have a rectangular opening, and it only gives us a length. So if I make my opening here, and I don't have to draw it to scale, it's a rectangular opening, so it's a rectangle. So we have 12 inches on the length, and we don't know the width. All right. It is a rectangle, which means we have right angles in the corners. And the area of a rectangle is the length times the width. So in this case, 12x square inches. It's 12x. So the point is we have a missing side here. We don't know what that extra side is, but we have a way algebraically to describe the area of this rectangle, and the area is 12 times x, so 12x, inches makes inches squared. We have two other smaller rectangular vents. One vent is 6 inches by 4 inches. The area of this vent, if we multiply the length times the width, and again this is a rectangle, so all right angles, 6 times 4 is 24 inches squared. That's the 6 inch by 4 inch vent. We also have an 8 inch by a 5 inch vent, so you don't have to draw these to scale. I'm just trying to sort of get them to scale here. 6 is not as big as 8. 8 is not as big as 12, right? 4, 5, right? I don't know what x is, so we can't really do anything with that. 8 inches by 5 inches. And again, this is another rectangle. We know the length, we know the width. So 8 times 5 is 40 inches squared. So again, they're describing these rectangles. I draw the rectangles and I find out what I can about them. They're talking about area, so that's what I'm worried about, is finding area of these rectangles. Once I've done all this, then I look at the relationship. It says the rectangular opening must have the same total area as these two rectangles. So that area has to equal the sum of these two areas. The total area would be the sum of these two, right? So I know that 12x should equal 24 plus 40. Notice I didn't put inches squared within the problem. I think it gets a little bulky to see an equation with all those inches squared thrown in there. But when you deal with addition, square inches plus square inches leads to square inches. Okay, so the fact that they're all square inches, they're all the same unit, fits with the problem. So 12x equals 24 plus 40, which means 12x would equal 64. So to get what x equals, I'm going to divide both sides by 12. And 64 divided by 12, it does reduce by 4 down to 16 over 3. Okay. And my usual feeling on solving equations is improper fractions are better than mixed numbers, right? But in the world of measurement, we typically, in measurement world, we would say 5 1/3 inches, right? We wouldn't say 16/3 of an inch, right? So the fact that we're dealing with measurement here, I would probably go to a mixed number on this. 5 1/3 inches would be a more appropriate answer to this. And notice the unit is inches. Here's why. Okay? If you consider what's going on here, I've got 12 inches times x inches. That's what 12x is. That's what made the 12x inches squared, right? So I kind of split it apart into what made that. And that equals 64 inches squared, right? When I divide by 12, I'm dividing by 12 inches. Inches squared over inches makes inches. All right, so that's kind of what's happening there. So we end up with a unit of inch. Length should always be units of inches. Area should always be inches squared. Volume would be inches cubed, or whatever unit we're dealing with in that case. So make sure, again, we're putting some thought into what the correct unit is, correct unit power, those kinds of things for what they're asking us to do.